Welcome back to Math 20-3. We are going to be going over chapter 1.2, and this is going to be hopefully a bit of review from Math 10-3, but it is something that a lot of students struggle with. So make sure you're taking down all the notes in this booklet, doing some practice problems, and coming in for some help, okay? Because we're going to do a bit of calculator work as well, which is something that can deem a little bit of a difficulty for some students. Now, in this 1.2, we're going to be talking about grade, angle, elevation, and distance. Now, all of these things essentially almost kind of interact and mean the same thing, okay? And we'll learn all of these different definitions. Now, remember, you have your formula sheet. This is found on your Moodle page. And we're going to be talking about the rest of these, okay? We're going to be doing slope equals 10x, okay? How to use that. Grade is the slope times 100%, okay? And that's going to be giving our slope grade percentage, okay? And we're going to be talking about that, doing a few examples together. And then we've talked about rise in 1.2. Or sorry, not rise, slope. Okay, so it's really important to remember Pythagorean theorem. A squared plus b squared equals c squared. Now remember, a and b can interchange. This could be representing a, this could be representing b. It doesn't really matter. The biggest important thing is that c is representing your hypotenuse, and that's across from your 90 degrees here, okay? So it's the one, c is always the longest length. It is the length that is at a diagonal, and it's easiest to remember, it's across from your 90-degree angle here, okay? Now, it's also important to remember, how do I solve, if I'm given C, and if I'm given A, how do I find B, okay? Anytime you're trying to find one of the legs that is not the hypotenuse, you subtract the hypotenuse from the other leg. So that means C squared, if I'm trying to find B, b squared equals c squared minus a squared, okay? Now recognize this is squared. You always got to remember to square root. So if we wanted to solve for what c is, it would actually be the square root of a squared plus b squared. People always seem to forget that you need to, in fact, square root your c value, okay? Now, there's a few new things you're going to be shown here. Is tan A equals opposite over adjacent, okay? Now, what does that mean? Well, that means when we're focusing on a triangle here, this changes depending on what angle you're talking about. This is an angle here, okay? These are the side lengths. Now, if we're talking about this angle, angle 1, okay, this would be, let's call this, let's name this side length Mr. Scaber, okay, and this side length Jim. So Mr. S and Jim. If we're in the perspective of this angle here, the opposite side to this angle is Mr. S. The adjacent, recognize adjacent simply means beside, okay? The adjacent side is Jim. Now, something important to understand is your hypotenuse, because you might argue, well, hypotenuse is beside the angle 1. The hypotenuse is only known as the hypotenuse. This is the only name it can be given, the only thing it can be, okay? So that means Jim is automatically the one adjacent to angle 1. So if we were to set this up, tan angle 1 equals, well, opposite, the opposite side length is Mr. S, over the adjacent side length, which would have to be Jim because this is the hypotenuse. So the adjacent beside angle 1 would be Jim. So that would be your tan angle ratio, okay? Now, if we did it in terms of this guy, let's call angle 2. Angle 2 is going to be different. Tan angle 2, well, what's the opposite side to angle 2? The opposite side is Jim this time. So Jim is going to go on the top. And the adjacent side, remember, hypotenuse can only be hypotenuse. So that means the adjacent side to angle 2 would have to be Mr. S. So recognize tan angle changes depending on what angle you're focusing on. You're never going to focus on the 90 degree, okay? It'll always be one of the two angles that is not the 90 degree angle, okay? And recognize that is on your formula sheet, okay? Tan angle is opposite side of A, adjacent side of A. It's not always going to be just simply A. You could just be whatever angle you're focusing on, okay? So you're also going to be using a lot of these equations here. So let us do a few examples. Now, recognize you can figure out the measurements of the angles, okay? So how do I do that? Let's say we want to figure out the measurement of this angle here, okay? And this is example 1. So I'm going to call this angle A, and I'm going to put a little a beside it. So we can set up our ratio for tan angle A. Remember, tan angle equals opposite over adjacent. Okay, that's on your formula sheet. Okay, tan angle equals opposite over adjacent. In the perspective of angle A, what is opposite? Well, it would be the side across from A. So this would be 2.5, okay? And what is beside angle A? This we do not care about. This is the hypotenuse. It can't be the adjacent, it is the hypotenuse. So that makes this angle beside angle A. So this is 3.9. Now this is the ratio of tan angle A. Okay, this is the confusing part. We need to solve for angle A. If you're actually trying to figure out what the angle is, you need to use what's inverse tan. So here, tan angle A is going to be tan inverse 2.5 over 3.9. Okay, so anytime we're trying to figure out the actual angle, you need to take your ratio and put it in tan inverse. Now, where do I find that in my calculator? So here, we will find it by pressing second, okay? We're going to press second, and then see how the blue is tan -1, and this is normal tan? Anytime you press that second button, you're being given what's in the blue lettering. So if we press tan -1 here, we can plug in 2.5 divided by 3.9. And that's going to give us the angle of angle A, which would be 32 point, and I'm going to round this up to 7, okay? This number is greater than 5, so this is 7. 32.7 degrees, okay? Now recognize 2.5 divided by 3.9, what is that? 2.5 divided by 3.9, that gives me 0.64, okay? So this number here in decimal form is 0.64. If we plug in tan, we know what this angle is, it's 32.7. So let's just plug in normal tan, okay? It's not the inverse or anything. Tan 32.7, that gives us, I'll delete that so we don't get a thing. That gives us 0.64, okay? So if you're trying to figure out what the angle is, you have to use inverse. If you're trying to figure out what the ratio is and you know what the angle is, you can just plug it in. And of course, this is going to take some practice, okay? So it's really important to be practicing your questions. So here's a worked out solution on solving for the hypotenuse, okay? Recognize they didn't forget to square root. they squared both these numbers, which is something also a lot of people forget about, and then they square rooted. So this side is 4.7 centimeters. And then they also solved for the angle of G, this angle here, okay? The opposite angle is 1.9, so they put it on top. The adjacent, which is not the hypotenuse, is 4.3, so they put it on the bottom. And they had to use inverse tan. They had to do tan negative, which is found here, second tan. And they put 1.9 dividing 4.3. And they got a solution of 23.8 degrees. Okay, so let's look at C together. It wants us to solve for this angle here. It's labeled E, so they want us to find E. They also want us to find F, okay? Recognize F is across from the 90 degrees, making this the hypotenuse. So if we go up here, remember, all of this is found here. C is your hypotenuse, okay? We're trying to solve for C as the hypotenuse in this case. So here, remember that C squared equals A squared plus B squared. Remember, A and B can be interchangeable. I'm going to represent this as A and this as B. In this case, they didn't use the letter C. The hypotenuse is represented as F. So I'm going to just replace this as F squared equals A squared plus B squared. Now, we can solve for what F is. F squared equals A squared, which will be 6.5 squared plus 9.4 squared. Okay, make sure you do not forget to square. Okay, so you could do that. I'm going to do this all at separate times. So I'm going to figure out what 6.5 squared is. First, you have a square button here that will square it. That gives me 42.25 plus, and then what is 9.5 squared? Well, 9.5 squared is 90.25. And remember, this equals F squared. This does not equal F yet. We can add these two numbers together. So 42.25 plus 90.25. Okay, and that will give me 132.5, and we can square root both sides. So F equals the square root, and that will give me 11. So I squared both sides. Remember, I need to get rid of that square, so I'm going to square root my answer, and it's going to give me 11.5 inches. So that's what F is. Now, how do we solve for E? Well, in this case, we're going to use tan, okay? How do we use tan? Well, tan is, remember, this is on your formula sheet. I'm going to just put angle E here because that's what we're solving for. And anytime we deal with tan, it is opposite over adjacent, okay? Now, what is the opposite side length to E? Well, that is across from it, which is 9.4. So tan angle E equals 9.4 dividing our adjacent side, which is 6.5. And again, why aren't we choosing it as F? We are not choosing it as F because F is hypotenuse. It can never be adjacent. So it has to be the other beside side length. Now remember, this is simply just solved for the ratio of tan. We actually want to figure out what this angle is. Anytime we're solving for angle, we use inverse tan. So tan negative 1, 9.4 over 6.5. And what is that going to give me? Well, remember, how do we plug that in our calculator? We are going to do second tan, gives us a negative, okay, 9.4 dividing 6.5, and that gives me 55.3 degrees, and that is our angle of E. okay? So make sure you copy this down. If anything was confusing, rewind it, or you can come ask questions. Now we know how to deal with slope. Okay, slope equals rise over run. Now, something to recognize with the rise over the run is something kind of new here. Slope equals rise over run. We'll recognize this is our rise and this is our run. Okay, so sometimes slope and tan are related, but I would simply just use our information from tan and slope and go from there. Now, you need to know something, 2 new words. We need to know angle of elevation and angle of depression. What are these things? Well, angle of elevation, if we draw a triangle out here, think about elevation, okay? This is our angle of elevation. An angle of elevation is something where you have a horizontal and then you rise a leg up. So this is the angle of elevation. Okay, angle of depression is where you have a horizontal, so a line that's straight, and then you go down from it. So this would be angle of depression. Okay, it has to be from the horizontal. This is not an angle of elevation or depression. This is just an angle. If we drew a line here, sorry, it should touch the triangle. If we drew a line there, this would be an angle of depression. Okay, it always has to be attached to a horizontal. So let's do a question together. A ski jump rises 3 feet over a run of 7 feet. Okay, so we have a rise over run now. We're dealing with slope. What is the length of the surface of the jump? Okay, so now you have to start using diagrams. Okay, they're always going to look like triangles. So simply draw your triangle and try and start figuring out, this is a 90-degree triangle, what we're talking about here. We're rising 3 feet and the length, and the run is 7 feet, so that's the horizontal. The question is, what is the length of the surface of the jump? Well, you're going to be going off this part of the jump, okay? So they want you to actually figure out what this is. This is our question mark. This is our length of the surface of the jump. We'll recognize we're dealing with a right triangle. So here, we could represent this as C, okay, because it's the hypotenuse, it's across from the 90-degree. I'm going to put this as B, and this is A. Remember, A and B are interchangeable. And we have an equation to solve for hypotenuses, okay? So in this case, C squared equals A squared, which is 3 squared, plus B squared, which is 7 squared. Don't forget to square your numbers. 3 squared, that's 3 times 3, which is 9. 7 squared, which is 7 times 7, is, I'm going to plug that in my calculator. So 7 squared, I'm going to actually just do 7 times 7, which is what 7 squared is. That's 49. Here, I can add my 2 numbers. Remember, this isn't C yet, this is C squared. Okay, that will give me 58. And I'm going to get rid of this square, I'm going to square root both sides. So the square root, and now how do I do a square root? That's a really good question. Well, if we look here, the blue has a square root symbol. So I need to get second to get to the blue lettering, square root. So you see our square root. Now I'm going to put 58, and that gives me a decimal. I'm going to round it to 7.6. So 7.6 feet. And that's how long the surface of this jump is. Now, on to 3B. What is the angle of elevation of the jump? Okay, well, let's talk about that. What is angle of elevation? Remember, we already have this triangle. I'm going to redraw it. It might look a little different, but it is the same one. Remember, this is 7 feet, this is 3 feet, and this is 7.6 feet. They should all have units. Okay. The angle of elevation. Remember, elevation means to rise or to go upwards, and that's from the horizontal. So this would be the angle of elevation. Okay. We're trying to figure out what this angle is. I'm going to represent it as just angle here. How do we solve for that? Well, we can use tan. We have the opposite, we have adjacent. So tan angle equals opposite over adjacent. What's our opposite? Well, it's across from our angle, which is 3, over the adjacent, which is 7. Okay, remember, why is it not this? It is not that because that's a hypotenuse. A hypotenuse cannot be an adjacent side length. Okay. Now we have the tangent, okay, or sorry, we don't have the, well, we have the tangent ratio, but we're trying to figure out what this angle is. Remember, when we're trying to figure out angles, we need to take the inverse of 3 over 7. So again, I'm going to do second tan to get to the blue tan -1, 3 over 7. And that will give me 23, and I'm going to round it to 0.2 because this is greater than 5, so it rounds the number to the left of it upwards. So 23.2 degrees. And that is our angle of elevation. Okay, let's see what this is. A wheelchair ramp is being built to rise the landing that is off the ground. Building regulations say the ramp can be maximum. Okay, so this is going back to a little bit of our last 1.1 unit, which is all good. We need to be able to interconnect all of these sections. So a wheelchair ramp is being built to rise to a landing that is 2.4 meters above the ground. Building regulations say the ramp can have a maximum rise of 2.5 centimeters per 30 centimeters of run. So what is this? Rise over run. So we have a slope. And every time we rise 2.5 centimeters, we have to go over 30 centimeters. So our slope equals 2.5 centimeters for every 30 centimeters of run, which is quite a bit, okay? Now, we have a slope now. Again, we can technically get rid of these. Slope never has units. We just have to make sure the top and the bottom number to begin with have the same units. So 2.5 over 30. So slope equals 2.5 over 30. Now, they want us to know what the total run of the wheelchair is when we have 2.4 meters above the ground. So here we're going to use our cross multiplication, okay? So remember, 2.5 over 30, and we're always going to put rise on the top and always put run over the top. This time, we are rising the landing 2.4 meters above the ground, okay? So we're going to put 2.4 here and recognize this is in the units of meters. Again, the best part about ratios is once you figure out a ratio, we can use any other units, okay? And we need to know how much run are we going to deal with here. Cross multiply divide, okay? So cross multiply these two numbers. So that's 2.4 times 30. We're going to divide the odd number out, which is 2.5, okay? And this becomes 2.4 times 30 divided by 2.5, and that gives me 28.8. And what is this going to be measured in? Well, it's related to this number. This number is measured in meters, so 2.8 meters. Okay, so that was a little review of our last unit, which is cool. Now on to B. How long will the ramp be? Okay, well, if we draw out our diagram, we rise up 2.4 meters and we go for a run of 28 meters. Remember, this is our 90 degrees. It wants us to know how long this guy is. I'm going to leave it up to you to use Pythagorean theorem to solve for, we're going to represent this as c. Remember, this is the hypotenuse, c squared equals a squared plus b squared. You should know how to solve this at this point. Okay, if you don't quite remember, go and rewatch 3a. Okay, and then practice solving for b. I will be looking for your work to solving for b here. Okay. Now, I think we're coming up here on kind of the last thing, but now we're talking about percent grade, or also just known as simply grade. Okay, this is used a lot in mountaineering, so people who climb, who mountain bike, they talk about the grade of the ramp or the grade of the slope. Okay, lots of people in areas where they're building ramps or bridges need to know this kind of stuff. And it's simply, all it is you're taking your slope decimal and making it into a percent. Okay, now this is on your formula sheet. Grade equals slope times 100%. Okay, so take your slope, 100%. You know how to find slope now. So let's do that together. So this isn't super difficult if you know how to find slope. Okay, again, if something's confusing you, please just let me know, but we'll figure this out together. So number 7. So that water will drain properly, a patio attached to a house should slope downward about 2.5. Remember, how do we put this into decimal? Well, that's number 2 is before the decimal, and then 1/2 represents what's after. 1/2 is 0.5, so this is 2.5 inches for every 10 feet of run. Calculate the slope. This is really important to understand. When you're dealing with slope and you're doing that initial rise over 1, these two, rise and run, need the same units. Once you have the slope, you can use different calculations using different units. But that initial calculation to calculate slope, they need the same units. So here, we're going to have to do a little bit of extra math here. I'm going to change this into inches. They give us this. For every 1 foot, there is 12 inches. This is a ratio. I'm going to put inches on the top and feet on the bottom. So for every 12 inches, there's 1 foot. If I want to figure out how many inches is this, well, I'm going to put my 10 feet on the bottom and put X on top, which represents the amount of inches in 10 feet. Cross multiply, divide, super useful. 12 times 10 divided by 1. That gives me 120 inches. Okay, so now we know what 10 feet is in inches. It's 120 inches. And remember, this is our run. Okay, so here, to figure out our slope, we need to put rise, which is 2.5 inches, over our run, which is 120 inches. Recognize they're both the same units. That initial calculation, you need the same units. Now they cancel out and you get 2.5 over 120. Now what's happening here is we have a decimal. We talked about this in 1.1. We need to get rid of that decimal. Multiply both sides, top and bottom, by 10. You get 25 over 120 times 10 gives me 1200. Okay, and now this number is a 100 number, so I know it's divisible by 25. So let's divide the top and the bottom by 25. Again, you might first off trying dividing by 5, which is cool too. You can do it in multiple steps. 25 divided by 25 gives us 1. 1200 or 1200 divided by 25 gives me 48. So our slope here is 1 over 48. Okay. So we figured out slope, which is totally awesome. And now we can figure out a few other things. So remember, we needed these in the same units. Now, if we were to say, given a different type of question where it asked, we build a patio that has 100 feet of run, you could simply just use feet, okay? Now, how do we figure out the percent grade here? Remember, it's on our formula sheet. Where are we here? Still going up. Our formula sheet, grade equals slope times 100%. So we just need to take our slope and times it by 100%. So here, grade, which is short for percent grade, equals slope times 100%. Okay, what is our slope? Well, our slope is 1 over 48. We're going to put that into a decimal. So slope here is 1 over 48 times 100%. How do we write this? Well, this is 1 divided by 48. So 1 divided by 48 times 100%. 1 divided by 48 times 100%, which gives me, 2.08. So I'm going to round that up to 2.1 because this number is greater than 5. So 2.1%. And that is our percent grade. Okay. Again, you could probably hopefully see if you increase that percent, you're getting steeper and steeper and steeper. So obviously you don't want your patio to be that steep. Alrighty, so we're pretty close to being done here. We just need to figure out what pitch is, okay? The slope of a roof is often referred to as its pitch. That's all it is. Pitch, this new word, simply just means slope, okay? It's just something contractors use when they build houses. So in this case, the pitch would be from here to here, and this pitch will actually be different than this pitch because we can see that this side of the roof is at a bit of a bigger angle than this side of the roof. So pitch simply just means slope. So you should be able to essentially answer most of these questions at this point. I'll maybe do 11 with you here, and then we'll see if we can leave the rest for homework. So a roof of a tool shed has a pitch of 2 to 5. If the shed is 7 feet wide, what is the rise? So remember, pitch is simply just slope of a roof. Okay, so we have a roof here, and it has a pitch or a slope of 2 to 5. What do these numbers represent? Remember, this in a fraction is the top number, the left number, and then the bottom number is the right number. If this is slope, this simply means that this is rise over run. So check it out. Now we have a way to represent rise over run in terms of pitch. So a roof of a tool shed has a pitch of 2.5. If the shed is 7 feet wide, what is the rise of the roof? So now we have a ratio, we can solve and do cross multiplication division. So this guy, 7 feet wide, that's your run. And how many feet do we need for the rise? Well, we need to follow this ratio. So 2 over 5 equals, remember this is run, we're always going to put on the bottom, 7 feet over rise. And in that case, we can cross multiply and divide. So here, 2 times 7 divided by 5. And that's going to give me 2 times 7 divided by 5, which gives me 2.8. Okay, so now we have what is the rise? Rise over run. I think they might have given the wrong solution here. let me just check my understanding really quickly. Even I make mistakes once in a while. So see, they just converted pitch to slope. Super simple, right? And then if you know how to deal with slope, you're good to go. The roof of a tool shed has a pitch of 2 to 5, which is simply 2 over 5 in terms of slope. If the shed is 7 feet wide, what is the rise of the roof? So unfortunately, they have gotten the solution wrong here. This should really say 2.8 feet. I'm going to check my math one more time. 2 times 7 divided by 5 gives me 2.8. So yeah. Then they divided it by 2. Oh, I see. I'm actually not doing this properly. This is why it's very important to draw a picture. So here, the roof looks something like this. So it's actually good to see your teacher make mistakes sometimes, because that's what problem solving is. You make mistakes, you got to figure out what happened. In this case, this is 7 feet wide. They want you to figure out the rise here, but recognize we want a right triangle. So this is the triangle we're going to use to figure out how high this is. Okay, so that means this is actually half of 7. So 7 divided by 2 gives me 3.5. So our triangle we're dealing with is 3.5 feet. Okay, and we're trying to figure out this guy, and this is a 90-degree angle here. So we should actually be putting 3.5 feet. So super important, okay, draw pictures. I haven't been drawing pictures very much, and you should be drawing pictures. So 2 times 3.5 divided by 5. So they did have the right answer. I jumped the gun a little too quick there. So 2 times 3.5 divided by 5 gives me 1.4 feet. That's how high it is. Okay. Let's see if you can So definitely try number 2 out on your own. You should be able to solve that. If you're having issues, please contact me or come in. And realistically, you should be able to solve for the remainder of these questions, okay? I might do 4 as one more review here, and then I'll leave these last few questions to try it on your own. So number 4 says, Ariana is installing a pipe for drainage. The system requires a drop of 1.5 centimeters for every 2.5 centimeters. So we have a system where every time we drop, which is technically our rise, every time we go down 1.5 centimeters, we need to go over 2.5 meters. So we're trying to figure out the slope of this thing. Slope equals rise over run. Now it's huge to remember this initial calculation. You need to make sure you're working in the same units, okay? When you do number 5, you need to be working in the same units, okay? So here, before I plug these numbers in, these need to be in the same units. So as the system requires a drop of 1.5 centimeters for every 2.5 meters. I'm going to convert this into centimeters. They give us a ratio here. Remember, we can use that ratio. I'm going to put meters on the top, centimeters on the bottom to solve for this. So 1 meter is 100 centimeters. I'm converting 2.5 meters into centimeters. So this will be 2.5 times 100 divided by 1. And that gives me 250 centimeters. Okay. So now I can plug this into my calculation. This is 250 centimeters. Okay. I'm going to give myself some room here. So remember, it's rise over run. So my rise is 1.5 centimeters. and my run is 250 centimeters. Now that I've plugged it in, I can get rid of the units. And I also recognize there's a decimal here. I'm going to multiply both top and bottom by 10. And that's going to give me 15 over 250 times 10 is 2,500. Plug that in your calculator. I'm going to maybe check. It's always good to check. And now I'm going to see what I can divide these things by. So maybe I try and do 15 divided by 3. Okay, so that does work, but I have to make sure that bottom number is also divisible by 3. So 2,500 divided by 3. That doesn't work. Okay, let's try 5. 15 divided by 5. That works. Let's check if 2,500 is divisible by 5. That works as well. So I'm going to divide both these numbers by 5. And that's going to give me 3 over 500. And that's our solution there. Okay. Now, how much drop will she need if the horizontal distance is 12 meters? Remember, we now have a ratio that we can use, rise over run. For every 3 rise, we have to go 500 over. So 3 over 500 equals, well in this case, a horizontal distance of 12 meters. That's our run. This is the run. And then we're trying to figure out what the drop is. Drop is also known as the rise. Okay, we're not talking about going up. In this case, we're just talking about going down, which is the same thing in terms of rise over run. And now we can cross multiply, divide. So 12 times the cross number, which is 3, and divide by 500. 12 times 3, divide by 500. That gives me 0.072, and recognize we were measuring in meters, so this would be in meters. You could technically convert it to centimeters and get 7.2 centimeters if you would like. Now, what is the angle of elevation of the pipe? Okay, if we draw, I believe we are talking about this pipe. So if we want to draw out what this pipe is, it's going to be a right triangle. And we are going over 12 meters, and we are dropping 0.072. If you're more of an arrow guy, we'd be going down there. The angle of elevation, remember, is this angle. It's going up, elevating. So this is the angle we're trying to find, and we're going to use tan angle. So that is, remember, tan angle equals opposite over adjacent. Okay, our opposite angle is 0.072. Okay, it's from across from it. And our adjacent angle, it won't be this angle, or sorry, adjacent side won't be this side because that's the hypotenuse, so it has to be this side length, 12. And what we're going to do is, remember, we're solving for angle. So we're going to do inverse of tan, 0.072 over 12. So here, tan inverse, 0.072 over 12. And that gives me 0.343. So I'm going to round that up to 0.34. So 0.34 degrees. So a really small incline, barely anything at all, which is hopefully what you would want for a piping system, because anything bigger, you're going to have issues. So that was a good review of pretty much the whole 1.2 section. I'm going to leave 5 and 6 and 7 for you guys to try out on your own. 7's a little bit of a test of knowledge for you there, but you should definitely know how to do 5 and 6. So make sure you're giving those a shot and asking questions if you need. Other than that, thanks for watching everything. If you have questions, please come in and ask.